Hello students, welcome back to the sixth video of this playlist. So in this video we will be solving the last question from Statistics S1 May 2024 paper. So let's see what's the question number 6. The last question of this paper is about. So basically the concepts behind question number 6, it's from probability, like conditional probability, and the dealing with Venn diagrams, right? These stuffs, these topics has been discussed in chapter number 4, that is probability chapter of your statistics 1 textbook. Okay, so let's get started with question number 6. The Venn diagram shows the probabilities related to the teenagers playing three particular board games. Okay, C is the event that a teenager plays chess, S is the event that a teenager plays Scrabble, and G is the event that a teenager plays Go. Okay, you can see in the figure that a Venn diagram has been given where P and Q are probabilities. P and Q, you can see in the Venn diagram, P and Q. Okay, so the question asks here to find the probability that a randomly selected teenager plays chess but does not play Go. A randomly selected teenager plays chess but does not play Go. Okay, let's check the Venn diagram. Plays chess. Where is chess? Here you go, chess, right? Chess, but does not play Go. So plays chess. This is what? This is the whole circle, right? But does not play Go. So which part of chess is outside the Go circle? Which is 0.04 and 0.12, right? So that means this probability would be 0.12 plus 0.04, right? 0.12 plus 0.04, so that would give you what? 0.16. Understand? So the probability would be what? 0.16. This is the probability of a randomly selected teenager to play chess but does not play Go. Done. Next, for part B, they are saying given that the events C and S are independent. Okay, so now they asks in part B to find the value of P. Okay, we need to find out the value of P, and given that C and S are independent. Okay, so at first consider the probability of S. What's the probability of S? This is 0.23 plus 0.1, which is 0.33. I'm adding up the values. So 0.33 plus 0.15, this is 0.48 plus 0.12, this is 0.6. Okay, so this is the probability of what? S. Okay, so we got the probability of S. This is 0.6. Now this is the probability of playing Scrabble. Now probability of playing chess. Probability of C, since C and S are independent, so consider C now. C is what? 0.04 plus P plus 0.12, that is 0.12 plus 0.04, that would give you 0.16. So 0.16 plus 0.15, this is 0.31, right? Yes, 0.31 plus P. So this is 0.31 plus P. Now for independent, okay, before independent, probability of S intersection C is what? S intersection C is given as what? 0.12 plus 0.15, which is 0.27. Why I am finding these values? The reason is that if you have gone through chapter number 4, the concepts of chapter number 4, then definitely you know that for independent events, probability of S intersection C would be what? probability of S times probability of what? C. So probability of S is what? The probability of S is given as 0.6. So 0.6 times 0.31 plus P. 0.6 times what? P plus 0.31. This is equals to what? Probability of S intersection C, which is 0.27. Make sense? 0.6 times P plus 0.31, this is equals to 0.27 exactly. So we need the value for P. So 0.6 P plus what? 0.6 times 0.31. So this would give you 0.186 equals to 0.27. So from there make P the subject. If you make P the subject, what you would get? 0.27 minus 0.186 over 0.6. So this is basically 0.14. The value for P is 0.14. Done. We got the value for P. Now in part C they are asking to find the value of Q. Hence find the value of Q. So now it's pretty easy to find out the value of Q, because if you see the Venn diagram, you can see that Q is what? Outside all of the what? Circles, right? So if you add up all of the probabilities and then subtract them from 1, you will get the probability of Q. So let's add them up. What you will get? 0.04 plus what? 0.14, which is 0.18. 0.18 plus 0.12, which is 0.3, plus 0.15, it is 0.45. 0.45 plus 0.1, which is 0.55, plus 0.23, that means 0.7. What? 7. 0. What's that? 0.77. So the probability of Q would be what? Q would be what? 1 minus the sum of all of the probabilities. Okay, so let's move on then. We need the value for C. Hence they said hence. So the value for Q is what? 1 minus the sum of all of the probabilities, isn't it? So 0.04, 0.04, let me show the workings, plus 0.14 plus what? 0.12, 0.15, 0.1. So 0.12, 0.15 and 0.1, 0.12, 0.15, 0.1 and 0.23. So it would give you 0.78. Yeah, because 0.55 plus 0.23, it gives what? 0.78. So we'll get 0.22. The value for Q is 0.22. Done. Next, part D. For part D, what they have asked there, find probability of C union S. C union S intersection G prime. C union S. Okay, let me erase all of them. So C union S is which part? The circle C, the whole C, right? The whole C, right? C union S, the whole circle intersection G prime. G, not G, that means not G. Okay, not G is which part? This is this part, right? 0.04, 0.12 and 0.23. So this value would be what? 0.04, 0.04 plus 0.12 so this is what? 0.04, 0.12 plus 0.23. Okay, 0.04 plus 0.23 plus 0.12, right? Okay, 0.04 plus 0.12 plus 0.23. Okay, so what would be the total? That would give you 0.04 plus 0.12, this is 0.16, so this is 0.39, this is 0.39. That's the answer for part 1 of question D. Next, for part 2, they are asking for what? They are asking to find probability of C given S intersection G, right? C given S intersection G. So which part is S intersection G? Which part is S intersection G? So S intersection G is basically which part? S intersection G. Okay, S intersect G, this part, right? S intersection G. This part is what? S intersection G. Okay, so they said C given S intersection G. So C given S intersection G would be what? C given S intersection G. This is probability of S intersection G. Okay, and on the numerator, it would be what? The common part of C. C given S intersection G. Okay, so in S intersection G, how much part is C? This is only 0.15, right? And S intersection G is what? 0.15 plus 0.1, which is 0.25, right? So you don't need to write like this, you can write it directly. What? That 0.25, and out of 0.25, how much is C? 0.15. So 0.15 over 0.25, that would give you how much? That would give you 0.6, exactly 0.6, and this is the answer for part B. Done. Next is what? Next is part E, right? So what they have asked in part E, a youth club consists of a large number of teenagers. In this youth club, 76 teenagers play chess and go. Okay, 76 teenagers play chess and go. Okay, now in part E they are asking to use the information in the Venn diagram to estimate how many of the teenagers in the youth club do not play Scrabble. Okay, so 76 plays in total chess and go, right? So what's the probability for chess and go? The total probability for chess and go is how much? Chess, this is chess, right? This is chess and this is go, right? So for chess and go, what's the total probability? 0.04 plus 0.12, which is 0.16. 0.16 plus 0.14, which is 0.3, right? So 0.3 plus 0.15, which is 0.45 plus 0.1, which is 0.55. Okay, so we got the probability of C union G, right? C union G, this is what? 0.55. So out of that, what they wanted in the Venn diagram to estimate how many of the teenagers, okay, in this youth club, 76 teenagers play chess. Oh, it says and. Okay. So since it is and, we will consider only the common intersection. And means intersection, yeah. And goes for what? Intersection, and or goes for what? Union, right? These are the what? Statistical terms, right? So this should be intersection G. So C intersection G is what? This is just P plus 0.15. So P is 0.14 plus 0.15, which will give you 0.29. Okay, so we got probability of C intersection G. This is 0.29. So for part E, probability of C intersection G, we got 0. How much? 29. So for 0.29, how many teenagers? For 0.29 probability, number of teenagers is what? 76 teenagers, right? Now, 1 probability, how many would be in total? 76 over 0.29, unitary method, isn't it? Teenagers. So for how many we need? They wanted the number of teenagers who does not play Scrabble. Okay, so who doesn't play Scrabble? Okay, Scrabble, how many? What's the probability of not playing Scrabble? This is what? Just P, right? Just P is the probability who does not play Scrabble. Like within the intersection of C and G, P is the probability that amount of teenagers does not play Scrabble. So P is what? 0.14, right? So for 0.14 probability, okay, or is it condition? Use the information in the Venn diagram to estimate how many of the teenagers in the youth club do not play. Okay, they said specifically 76 plays chess and go, and the total number is not mentioned, right? So that means it is not conditional. It's basically considering the whole what? Number of teenagers, right? So in that case, we will not need to consider only within the intersection of C and G. We have to consider the whole, like as a whole, how many are not playing Scrabble. Okay, because they wanted in the youth club, how many of the teenagers in the youth club do not play Scrabble. So that would be what? The total probability of teenagers who do not play Scrabble. So this is 0.04 plus 0.14 plus 0.22. So that would give you what? 0.104 plus 0.14, this is 0.18 plus what? 0.22, it is what? 0.4. Okay, so this is 0.4. So that would be not conditional definitely. So it would be for not 0.14, we need for 0. How much? How many teenagers, like how much proportion of teenagers do not play Scrabble? This is 0.4. Okay, probability, how many teenagers? 76 over 0.29 times what? 0.4, that much teenagers. So what would be the value? 76 over 0.29 times 0.4. So this is basically 104.827. So 104.827, something like that. So we can consider round it up to say 105 teenagers. Okay, going outside, teenagers, that's fine. So that's the number of teenagers who do not play Scrabble in this youth club. And that's all about question number 6 from S1 statistics 1. May 2024 paper, and that's the last question of this paper. So in this playlist I have tried to explain as much as possible, so the length of the video is a bit longer, so you can like make it faster, like 4 into or 2 into, and you can watch it by making it faster. So this was all about this paper, statistics 1 May 2024 paper, and thank you for watching. That's all.